So now we've got function notation. This is function notation, y equals f of x. Now, you can use different letters for the x or the y or the f, but it would be basically in this form. F here is called the name of the function. Okay? Well, it's not called that. It is that. We also use G and H commonly. Those are just next in the alphabet. Then we use this Greek F called phi. This is a psi, psi. It's commonly used. Log is sometimes used if that's a specific kind of function, is a logarithm function. We use log. This is ln, that's a natural log. That's the name of the function. We'd use it instead of f, but that's a specific function called the natural log function. exp is an exponential function. We don't use that in here, but engineers use that a lot for what we call an exponential function. We do exponential functions, but we don't usually write it this way. But a lot of engineers do. Sin is short for sine, slightly short. That's a trig function. So f could be a trig function. Cosine is a trig function, tangent, inverse sine function, etc. And we'll do all these functions later in the course. So you could have a specific name of something or kind of a generic name like f, g, h, phi. Okay? So that's the name of the function. X here is called the first coordinate, or the independent variable, or the input. It's especially called the input when it takes on a specific value, like 5. It's also called the argument of f. And so argument is a little different than input. So if you have f of x squared, you're still going to think of your independent variable as x. But the argument of f is the x squared. So your argument of something is whatever's inside that something. So argument of square root of x squared minus 1 is x squared minus 1. It's the thing inside the square root. And so I do use that term sometimes, and we use it a lot with trig functions. Okay, so y is the second coordinate, or dependent variable, or output. And f of x is y. That's what it says, right? F of x is y. So f of x is the output. So f is the name of the function, x is the input, f of x is the output. I think of it that way. Also known as a dependent variable and second coordinate in your ordered pairs. So the basic idea as far as inputs and outputs is you're thinking of, you have this set of inputs which are represented by this box. So just think of it as items in this box or this rectangle. And then you have the y values or the outputs, and f takes each input to an output. So you can think of f as a process. It changes x values to y values in a sense. Changes inputs to outputs. So note that function notation is sometimes used for relations that are not functions. Okay, so for example, this is really common. F of x equals plus or minus square root of x. This is not a function because, as we saw before, the input 4 goes to both 2 and minus 2. So it's not a function. But we still use the letter f, and we still use function notation. So you'll have some problems where it'll say, does this formula represent a function? And if they gave you this one, you would say no. You wouldn't say yes because it's written in function notation. Don't let yourself get confused. So function notation is used for things other than just for functions. It is most often used for functions, though. So anyway, that's it with that.